Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question, question number 14, question number 19 of JEE Advanced Physics Paper 1, Code 8, 2014. So students, let us solve the next question, which is question number 19. It says a horizontal circular platform of radius 0.5 meter is a circular platform of radius 0.5 meter and mass 0.45 kilogram. So this is radius is 0.5 meter and mass is 0.45 kilogram. It's free to rotate about its axis. So this can rotate about this vertical plane. The disc can rotate like this in a vertical, horizontal plane and a vertical axis. Two massless spring toy guns here to. So let me draw a diagram for you. This is the circular disc and this is suppose the diameter and this is the vertical axis. This is the vertical axis about which this is rotating or about to rotate. When two toy guns, one from here fired like this and another here, the guns over here, each carrying a steel ball of mass. So mass of this ball is 0.05 kilogram each. Here also 0.05 kilogram. Attached to the platform at a distance of this distance is 0.25 meter both sides. From the center on its either side along its diameter, this is the diameter. So this radius is 0.5 meter. So halfway mark, there are two balls placed here and they have to be fired. Each gun simultaneously fires the ball horizontally. So it fires like that in this direction and this fires in this direction. The ball will go like this and this ball will go like this with certain speed. Okay. Next is perpendicular to the diameter in opposite direction. After leaving the platform, the balls have horizontal speed of 10⁻⁹ meter per second. After leaving the platform, so when it fires this speed becomes 9 meter per second, and also here it is 9 meter per second. With respect to the ground, this is a speed with respect to the ground. The rotational speed of the platform is in radian per second after the ball leaves the platform is. So this platform will rotate because this mass is creating angular momentum in clockwise sense. This is also in clockwise sense. So when you fire a ball from here, this moves like that, and this also moves like that. So to rotate the platform and rotate the platform with certain angular velocity. Suppose that the angular velocity is omega that you define. This is based on the principle of conservation of angular momentum. So we'll apply principle of conservation of angular momentum. So applying conservation of angular momentum principle, the angular momentum at the time of firing that will rotate the disc or the platform. So you can see that this is fired with this is the mass fired with this, and this is about this point it will rotate. The angular momentum about this point, suppose this point is O, is mv and this one is r. So this is mass, this is velocity, this distance is r, and from this side also it is mv into r, and they are in the same sense. You will add or multiply by 2. So we have 2 times mass of the each ball, that is 0.05 kilogram. V is 9 mb, r is 0.25. This is the angular momentum of the balls together, and that will provide you the angular momentum of the rotating wheel. So when the wheel rotates, or the platform rotates, it will rotate about the vertical axis. So if I consider this as a disc, this platform can be considered as a disc, and the moment of inertia of the disc about an axis passing through its center and perpendicular to its plane is given by half mr square. So we'll use half mr square, half mass r square. So that is your I, and angular momentum will be I omega. I'll put I omega. Then let me solve this first. Then omega is this divided by I. So omega will be this number. This is 0.05 9 0.25 divided by I. I is half mass of the platform, which is 0.45, and r square, r is 0.5 into 0.5. So this two will go up, this will become 4, and this is 0.505, so it is 45. This is 9 5 the 45.45. This will cancel out, and this is 0.25. This will become 0.25. That will also cancel out, and omega comes out to be 4 radian per second. That means this will rotate with angular speed of 4 radian per second. So this is a very simple question based on conservation of angular momentum. We equate the, or write the equation for conservation of angular momentum, and balancing that, we get the value of omega. Because this is provided, this angular momentum or rotation, angular velocity of the platform is provided by the momentum caused due to the firing of the ball. When this fires, this moves in this direction, then it exerts a force in the platform, because the platform then starts rotating with this omega. Okay, thank you.